I took number 38 and I altered it slightly. I took half of two problems, but that's okay, just to practice, make sure that we saw all combinations. And I'd like to find the sine of the difference and the cosine of this difference. Kind of alternating what we did last time. Yeah. To make sure that we touch on everything. So, again, I am aware that this is the sine of alpha cosine of beta minus cosine of alpha sine of beta. The ordering is extremely important for a sine. Cosine, that's cosine of the first, cosine of the second, plus sine of the first, sine of the second. And that's pretty much what it is. I need the sine and the cosine of each of those, and I'm done. And as for part B, I need the cosine, cosine, and the sine, sine, and there it is. Now, I'll go on the side, say, okay, well, let's look at alpha. As far as alpha is concerned, tan of alpha equal 5 over 12. What quadrant is alpha in? Well, it's between pi and 3 pi over 2. That tells me it is in quadrant 3. There's alpha. And as far as tan is concerned, this is opposite over adjacent. This is 5, this is 12, and this is 13. What do you know about those? They're both negative in this quadrant. And out of alpha, I need 4 values right there. I need the sine and the cosine. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And cosine again. And sine. So you notice you're doing the same thing over and over. As far as beta is concerned, beta happened to be between pi over 2 and pi. Well, pi over 2 and pi is right there. Beta is in quadrant 2. And it's very important to get that right. And this is radical 3 over 1. Keep in mind, this is a standard angle. I could use that to my advantage if I wish, or I could just do the triangle. That is the opposite over the adjacent. And we know here that this is a negative 1. That makes this a 2 if you use Pythagorean. And what do we know? We need sine and cosine. If I need tangent, I could figure that out as well. And here I need the cosine adjacent over hypotenuse. Oops, positive. Opposite. And cosine again. And adjacent over hypotenuse. Sorry, opposite. And again, for my students, get me this far and me and you are very happy. And that's pretty much it. The next set of problems is really identifying or establishing some identities, and if you remember how these work, I keep an eye on both sides of the equation. It would be wise to start with, sort of speak, the more complex side. Not much I could do with that, but this, I know what to do with a cosine of a sum. That is cosine of the first, cosine of the second, minus sine of the first, sine of the second. And cosine of pi is negative 1 times the cosine of theta. Sine of pi is 0 times sine of theta. And remember, you're only allowed to play with one side of the equation. That's negative cosine of theta, and that's a 0, and that's pretty much what I have on the right-hand side. So, I work with those. With these identities, it's kind of fixed what you could do, meaning a tangent with a minus, I know exactly what to do. That's tangent of the first. Again, I provide the formula for tangent. You don't need to memorize. You need to memorize sine and cosine. Tan of 2 pi minus tan of theta over 1 minus tan of 2 pi times tan of theta. And that is a 0 minus tan of theta, 1 minus 0 times tan of theta. This would be a 0. That's tan of theta over 1, which is tan of theta. And that's pretty much it. So identities here, the good news, you can only match a problem to almost a single identity. I look at number 60, it looks a bit more challenging at first glance than it actually is. If I think about it for a minute, I know exactly where to begin. That is, I know that not much I could do with this, but hey, isn't this the cosine of alpha cosine of beta minus sine of alpha sine of beta? Despite the fact that I'm working fast over those, I suggest when you get to those, work slowly at them. And cosine of alpha cosine of beta, and wouldn't that be plus sine of alpha sine of beta? And do you notice that those two cancel out? And you're left with one of those plus one of those. Isn't that twice the cosine of alpha cosine of beta, which is what you want? So here, things, I think, work nicer than the traditional. If I look at number 68, in my mind, the right side is more complex than the left side. Because I know what the left side look like. That's like the cosine of the difference over the sine. The right side has a bunch of cotangents. Since there are no squares from previous sections, we write this as cosine of alpha over sine of alpha times cosine of beta over sine of beta plus 1 over 1. We write that as a fraction. And this would be the cosine of beta over sine of beta minus cosine of alpha over sine of alpha. And here the LCD for the top and the bottom combined. Remember, this is a complex fraction. To clear it, you make sure they all have the same denominator. This already has it. This you multiply by sine of alpha sine of beta, top and bottom. I wrote it wrong. There we go. Much better. And here, this is missing a sine of alpha. And this is missing a sine of beta. And we know from the previous sections, this becomes the cosine of alpha cosine of beta plus sine of alpha sine of beta over sine of alpha cosine of beta minus cosine of alpha sine of beta. Basically, we ignore these denominators completely, if you remember correctly, and we get the top. And hey, isn't that top cosine cosine, isn't that the cosine of alpha minus beta? And isn't that denominator sine cosine the sine of alpha minus beta? And what's cotan over sine? Isn't that the cotangent as long as the angle is the same? And isn't that what I want? And I know you'd be thinking, oh my god, this is magic. No, it's not. It's math. Awesome, huh? Okay, let's do another. I have 3 problems to go. And let me see if I can finish them within the time allowed. I want to do number 76 first. Even though I put it there because of the size of solution, it doesn't need that much. This is a standard angle. The inverse sine of radical 3 over 2 from 2, 1 and 2, 2. I know that's an angle, and that is positive. And what would that be? The sine of which angle gives me radical 3 over 2? That would be pi over 3. And cosine of which angle gives me a 1? 0. So this is the sine of pi over 3. And the sine of pi over 3 is what? Radical 3 over 2. Just happened to match in this case. So if the angle is standard, I could use my unit circle or the triangles and go from there. If the angle is not standard, there is another way of doing this. I'll call this theta, and I'll call this beta. And I'm really looking for the cosine of theta minus beta. And I know what that is. That is the cosine of the first, cosine of the second, plus sine of the first, sine of the second. Using highlight is easier than trying to change each color. So what does that mean? Well, I have to go on the side. I have to go and say, well, look, for theta, it's not a standard angle. I need to draw the triangle. I need to know which quadrant I'm in. And I know that tangent inverse is positive in quadrant 1. All the inverse trig functions are positive in quadrant 1, so there's theta. So in this case, this is the opposite over the hypotenuse. I'm sorry, adjacent. Opposite over adjacent, that makes this a 12. Got it. And out of that, I need two values. Do you see where they are? I need the cosine. The cosine is the adjacent over the hypotenuse. Oh my god, I'm messing things up big time. And the sine is the opposite over the hypotenuse. And if I look at beta, I really let beta, the sine of beta equals negative 3/5. That means I am in quadrant 4 because inverse sine is only allowed to be in quadrant 4 if it's negative. Opposite over hypotenuse, that's a negative. I know that's a positive 4. And out of beta, I need two values as well. And those would be the cosine, that's the adjacent over the hypotenuse, and the sine, opposite over hypotenuse. So again, excuse me, oh man. And again, for my class, we're done right there. You don't need to simplify any of this. See, that's the benefit of taking CASP. All right, one more to go. And the last problem I want to look at would be this problem, number 88. And here it says, write each trigonometric expression as an algebraic expression. Write each trigonometric expression as an algebraic expression containing u and v. This is what you need in calculus. This is something that comes up. Again, I know this is not a standard angle. I'll call that theta, and I'll call that beta. I'm going to use the highlight. That's easier to do than me using different colors on the angles. So I know this is the sine of theta minus beta, and I know what that is. That is the sine of theta cosine of beta minus sine of beta cosine of theta. So give me those four values and pretty much I'm done. And let's see how that works. Well, again, if I use the highlights, this is what I need out of theta, and this is what I need out of beta. Oh boy, it didn't register. Okay. There we go. So as far as theta is concerned, I let theta equal the inverse sine of u. That means the sine of theta must have equaled u over 1. And if I draw my triangle, I realize that they didn't tell me whether u is positive or negative. Unless they state, I'll assume it's positive, and that's going to be the case all the time for us. And I know this is the opposite over the hypotenuse. If I use Pythagorean theorem, this will be 1 minus u squared. Out of that, I need a sine and a cosine. Sine is the opposite over the hypotenuse, and cosine is the adjacent over the hypotenuse. And I need to do the same thing for beta. So I take beta on the side, and I say, well, if you let beta equal the cosine inverse of v, that means cosine of beta must have equaled v over 1. And again, they're never going to tell you that v is negative. That's the good news here in calculus. So you're going to assume you're in quadrant 1. This is beta, and this is the adjacent over the hypotenuse. Adjacent over hypotenuse. That makes this the square root of 1 minus v squared. And from beta, I need the cosine and the sine. Well, cosine would be the adjacent over the hypotenuse, and sine would be the opposite over the hypotenuse. And that pretty much takes care of this section. It's a long section, not that hard, just a bit tedious until you get the hang of those identities. I'm going to give you the homework in a minute. And here's the homework on the section.